So welcome. This class is going to be called Cairo Lang 0 to 1. So yes, I'm the host. I'm Okai Omatobe, and I'm teaching this Basecamp. So to get started, I'm going to give you a little bit about the Basecamp. So this Basecamp is a Starknet Foundation initiative. It is used to onboard devs to Starknet. It's going to be taught over a course of 6 weeks, and it's going to be a weekly class or every Tuesday, about 2-hour session. I'm going to try to keep it lower than that, but let's just say they estimate to be averagely 2 hours. Today is going to be a bit of an introduction, so it's probably not going to last up to 2 hours. I just want to kind of get you all up to speed with the foundation or the fundamentals of Starknet. And the class will heavily be on Cairo, though. You can use the chat during this call. There'll be Q&As, quizzes, and then homework. There will be like the Basecamp or Discord you can join. I'm going to send the link after the class. And then there will be a YouTube channel for watching the pre-recording. So this class is going to be recorded. Give me a second. I don't think I'm recording right now, so I will do that. Oh, wait, I'm recorded. So yeah, the class is going to be recorded, so you can always reference it if you missed the class, or if you just want to use this as a reference for whatever use case you have. So for the next slide, so we are currently at the fundamentals. So today we're going to go over the fundamentals. So I'm just going to try to get you up to speed. I know some people have taken this class before. We can still try to see catch them up to with the fundamentals, but you can also reach out to me if you have further questions. I would give you more information as we go in. So the next session will be on Cairo, and then the third will be on Starknet and smart contracts. The fourth will be on front end. We would have another teacher going over the front end. Then we would go over Dojo, which is an on-chain gaming engine on Starknet. And the sixth class will be an open discussion. So we just try to catch up on everything that people missed. But also, I'm going to go over like a production contract, and we'll discuss a little bit about smart contract security. So who are the instructors of this class? There are going to be 2 teachers and 1 TA. So the first one is me, Okai. Victor is also going to be teaching, is the one teaching the front end, and then Prince is the TA. So if you all have any questions, please feel free to leave it in the chat, and I will try to answer it, but the TA will be here to also address that, and Victor. Okay, so we go over the journey. So right now we're here. So we start the Cairo Lang 0 to 1. It's going to last from October 1st to November 5. It's a 6 weeks class. We're going to be learning about Starknet and Cairo. And then in the week 2, it's, no, the second thing you could do here is the ODAC. So this is where you can contribute to open source projects written in Cairo. And there's ODAC every month, so you can always contribute to this every month, and you can get actually paid contributing to open source projects with this. There's another part where you build your own project. So I would encourage, if you've taken this class before, or even if you just started, if you have an idea or you want to just build your project, you could do it maybe during the course of this class or after this class, and you can, apply for a seed grant or a growth grant from Starknet. The seed grant is for early stage projects. I would talk more about it during this the course of the 6 weeks, and the growth grant is for already established projects, which I'm assuming most of you in this class will not be at this point. And then there is the Starknet account. This is another thing you can do in like the Cairo ecosystem, where completing this class or any Basecamp and like finishing some other things will be requirements to get into the Starknet accounts. So these are like some of the options you can do in your journey on the Cairo ecosystem or Starknet ecosystem. Okay, so this class, there will be like graduation spokes. So you will get a badge or certificate for completion. So these are some of the requirements. So there are 3 different spokes that you can achieve in this class. So the first one is attendee. So if you get about 25% of live classes attendance, but for whatever reason you could not finish the class, you get a badge for attendance, right? To get a graduate badge, you are required to attend more than 50% of the live classes. But if you cannot and you watch the video, you can also communicate this with me. I would consider that. And you should get about more than 50% of the total points. I would talk about that in the next slide. And for the final spot you can also receive is like distinguished graduate or cum laude. This is up to my discretion. Starknet Foundation would not, I mean, they want to keep this like really, limited. So it's like if you can show that you're like an exceptional graduate, definitely I would talk to the foundation to get you like a cum laude graduate spot. Then I'm going to go to the scoring of the class. So you can achieve a total point of 60. So there will be tests. So the test will weigh 40 points total. Completing Starknet. Starknet is like, it's an app where you can practice Cairo. It just gives you like a fundamental. We're going to actually go through maybe half of the Starknets during the next class or for the subsequent one. But you'll be required to finish everything to get 20 points there. And this is a total of 60 points. Then you can also get more points from like Node Guardian. So Node Guardian is it's a learning platform to learn about smart contract development, just not restricted to Starknet or Cairo. You know what? I'm going to show you. Okay, for some reason my network is not loading the application, but okay, it just worked. Okay, it's just slow. It's painfully slow. But I'm going to leave a link to the Node Guardian sites in the summary of the class so that you all can check it out. If you complete some of the quests, the Cairo quest here, you should get some points for that. So 10 points per quest. And you don't need to submit any proof. Like if you sign in with your GitHub, we can track that. And for people that have not submitted their GitHub, because it was part of like the requirements when you were signing into the class, I would ask you to like send me your GitHub account. I'm going to drop a form maybe at the end of maybe week 2, so you can submit your GitHub profile, so I can use this to track your completion of Node Guardian. And then there's another bonus activities. If you want to practice more on like Cairo, if you want to focus like on the algorithm, because this would help if you're probably trying to get a job in this space. Some of them would test you on algorithms, and this platform exercising would actually give you a good head start on like practicing like some algorithm solutions and using Cairo. It's similar to LeetCode if you're familiar with that. So I would recommend that you people try this. So there's point allocation for that. So 2 points for the easy ones, 4 points for the medium, 8 points for the hard one. And you will need to submit a proof of this to me. So I would probably ask you at the end of the 6 weeks to send me like screenshots of like proof that you completed the exercises here, so you can get some points for graduation. Okay, so we're going to get started right now in the fundamentals. Okay, what I just went over is just like the basics, and now we're getting into the main thing. So this is Starknet fundamentals. So this is how it's going to go. So this section will go over like why Cairo, which is the programming language we will try to go deep into. Winifred says she cannot hear me. Is it volume better now, Winifred? Can you leave a chat? Wait, can you all hear me clearly? Okay, volume is great for me. Okay. Oh, all right, awesome. Okay, so in this session, we're going to go over why Cairo, why Starknet, and then we'll take a break, and then we'll go over smart wallets. Okay, so before we go in there, I'm sure like in the ecosystem, or like if you have kind of like stumbled upon the Starknet ecosystem, you'll see so many logos. So you'll see like Starkware, StarkX, Starknet, and Starknet Foundation. There's like so many things might be confusing, but this is just like the Starkware is the company that is building like the product Starknet and StarkX, or they created it. Now Starknet is kind of like more permissionless. It's gradually decentralizing and giving to the community. But StarkX is like a similar product to Starknet that is built by Starkware, but it's more permissioned. It's like, we can think of it as the enterprise version of Starknet. And Starknet Foundation is a nonprofit that is governing StarkX. This is really not super important if you want to like just focus on programming, but it's a good thing to know like within the ecosystem, because you'll see this a lot. Okay, we'll go to the core of this. So why Cairo? So for me to explain why Cairo, I'm going to use like a space exploration problem. This might be a bit like, abstract, because I mean, we are building smart contracts, but this is a very good example of like why we are using Cairo in the first place, or why Cairo was built. So for this space exploration problem, let's just assume that you're a scientist for a country and you're trying to, maybe send a rocket to the moon, right? You hire engineers that build a program in Rust. So you want to kind of know how to save well, the best launch trajectory, or just the best trajectory. And you write a program that will help you calculate all this. But you have a problem. You cannot execute it because you don't have, enough compute power in your country. So you have to work with maybe a rival country or even anybody in general. So you get the program and you send it to this person or country that will help you execute it. But the problem here is that, they execute it, they send you the results. But how do you know that this result is true? It's not, the supercomputer did not malfunction, or they're not trying to sabotage you. For this, in this case, there's no way to know, because most programming language, especially the one we are using, or most programming language, Rust or Python or anything, don't generate proof of computation. So they just execute it and, they give you the result. So you just have to trust that, this is accurate. There's they're not trying to sabotage you. But what if there's a way you can? But with Cairo, you send this same program, they will send you back a result and a proof. So in this case, you don't have to just blindly trust that, they are not trying to sabotage you. Is that they sent you a proof that you can use to verify that, okay, given this program, this result is accurate and it was not modified. So in this case, we can use Cairo to keep a supercomputer honest. Again, I know this is a lot of abstraction for the practical use case. So we're going to go into a deeper example as we're going through this course. And in this case, we're using Cairo as the programming language for Starknet, which is a layer 2 solution for Ethereum. Again, if it's a lot of new concept to you, it's okay. I'm going to try to kind of slowly go through it. And if you have any questions, please feel free to leave it in the chat. And I will try to answer it as much as possible. Okay, so Cairo feature. So Cairo enables verifiable computation. Again, with the example I told you, if you've written a program in Rust or Python or any other language, it's very difficult for you to, it's impossible to generate proof of computation with just that language. But with Cairo, when you run a Cairo program, it executes and generates proof of computation. And this helps you to kind of verify the computation. Again, it runs on top of the Cairo VM. The syntax is inspired by Rust. It has similar ownership model. And when they say, okay, it has a similar ownership model with Rust and it's inspired by Rust, it means it's kind of easy for, it's easier for Rust developers to easily pick up Cairo. But I know if you're not a Rust developer, you can still pick it up. And this is the point of this class. And there's already a lot of more materials that helps you kind of learn it. Okay, Cairo is strongly typed. It has traits, macros, and it can be used outside of Starknet. So you're not limited to just using Cairo or with Starknet. So it's if I learn Cairo, what can I use it to do? Actually, what brought me into the Starknet ecosystem was Orion, which is a zero knowledge machine learning framework for generating proof of machine learning inference. So this directly does not associate with Starknet, but it uses Cairo. So, and in the future, there'll be more general purpose, programs built with Cairo, but it's relatively new. And so, in this case, in our use case, we're focused on Starknet. Okay, and also Cairo, you don't need to know ZK to use Cairo, and it might be a misconception because I know that initially I was hesitant to look into the Starknet ecosystem because I just thought it was going to be heavy math and I would not understand it, but and cryptography. But no, that's not the case. You can use Cairo as a regular programming language and you'll be okay. And in this case, I'm going to show you examples of Cairo program. Again, if it looks foreign, it's okay. I'm just trying to kind of gradually introduce you to what it will look like. When you're programming, you get to see this a lot. And even during the class, I'm going to show you examples. So, but I just want to give you a reference point with this. So this is how you define a struct or a custom data type in Cairo. So you use the keyword struct and then rectangle. And then these are scalar types, so use height and use64. That's unsigned integer, and width unsigned integer. So you just define a custom data type with this. Then there's traits, which you can use to create a functionality blueprint. So you're using this as a blueprint of shape geometry. So it says function boundary, and then self rectangle, and it also function area and self rectangle. So it just means that the arguments that's going to be passed into boundary function is rectangle, which is the custom data type you define here. And it's okay if you don't understand this right now. I'm just showing you examples. I'm going to kind of break it down further during the course of this class. And this is like an implementation block. You're implementing implement IMPL is a keyword, implementing rectangle of shape geometry, which is this. And then you're kind of like implementing the functions that you defined here in here. But again, it's okay if you don't understand this. I'm just trying to show you what it looks like down the class. Does anyone have any question right now? Good. Okay. No. All right. So I'm going to show you an example of a Cairo contract. So again, this can be used like as a basic program, but this is Cairo contract. So you see that there are macros here. So we have the Starknet interface, and we have a Starknet contract. So we put this here. It's a term called meta programming, and we say macros, and you just say it's a function. Actually, it's a Rust function that takes in Cairo contract and generates another Cairo contract from it. So when you wrap your program, like so you put a Starknet contract here and a mod simple storage, it means that this whole block of code will be the contract. And this is the interface here, and you're marking it here with Starknet interface. Put traits I storage. Again, I don't need to go deep into this. I just want to show you the examples. But and then you put the implementation block here. And if you put this macro here, it just means that, okay, all the functions here are public functions. So it's ABI embed v0. And you're going to see some like maybe ref self here and takes in contrast state. And you see self here and you're like, what's the difference? Why are you putting this one here? And why are you putting a ref here and you're putting a self here? And what's the at here? Well, it says that, okay, in this place, the reference. So if you put a ref self, it just means that it modifies the state of the contract. If you don't use a ref, you just say self and you take a snapshot. So you're just saying that this function will be read-only. It's not going to be modifying the state of the contract. It's going to be reading the state of the contract. And it says it outputs U126 here. So it says that this function will give you a result that is of type U128. So it's an unsigned integer. Yeah, and this again, every contract needs a storage. So for you to be able to compile the contract properly, you need to put a storage here. So it's like you put the macros storage and then struct storage, and then you put all the storage variables. Again, if you don't understand it, it's okay. I'm just showing you. When we go deep into we go into kind of explain it step by step. Okay, so this is a summary of why Cairo. So it enables verifiable computation. Again, you can think of the first example, although abstract, we're going to try to break it down as we go. So Cairo enables verifiable computation. It's proof of computation integrity, verification without re-execution. We're going to explain this a bit further in the next session, the next slide. And powerful and flexible language, it prevents cheating and malfunction, and it keeps the supercomputer honest. Okay, before I move on to the next slide, do you all have any questions on Cairo first? First question. Garrison says the ASH test are this called attributes of macros. Okay, well, I kind of interchange them. So yeah, they are attributes, but these ones are macros because again, they kind of like, they are used for meta programming. So they accept the code here and they use it to generate other code. But the ASH test is an attribute because you just kind of like marking that this is going to be a test. Christopher, nope. Hector says any alternative to Cairo. What do you mean? Can you clarify the question? Like, is there any other language that you can use to write on Starknet, or is there any other language that generates proof of computation? Can you clarify that? Like, is there any other language you can use to write on Starknet? And for now, it's Cairo. Because it was actually built specifically to write contract on Starknet. But yeah, there are no alternatives. That's a simple answer right now. One, you say, is it possible to study Cairo without having prior knowledge? So is it prior knowledge of programming or prior knowledge of like just blockchain? Can you clarify that question, please? Programming. It is possible. It's going to be difficult. It's probably easier to pick up like you know. So most times people recommend that you pick on like a language that's not strongly typed because it's not as restrictive. So like Python as your first language. But again, if you really want to study it, you can. You just have to spend more time, and ask a lot of questions. And I'm here for it. So if you have any question, I'm actually going to have like an office hour where you can ask me any question. There are no dumb questions here. So anything goes. But you will have to put in the work if you have no prior knowledge of programming. And you will have to probably use other study materials also, not just this class, but it is possible. It's more difficult. Okay. Is there any other question? I'm about to move on. More like prior programming knowledge. Okay. Okay, I'm going to move on. If you have any other question, you can save it to the end of the class. Okay, so L2, so why Starknet? So Starknet was created as a scaling solution for Ethereum. So there is this popular, like everybody knows about, like if you're in the blockchain space enough and you use Ethereum, you know about the L1 scaling problem that Ethereum has. So in this case, I'll just show you an example of like how Ethereum works. So a random validator is picked to become a block producer, and let's just say you produce a new block and it's like there's a state change and says the state is 42. In this case, all the other validators would not trust that this block producer is being honest. They would all have to, execute it. This is not the most efficient way, and it's like the transaction per section. Yeah, this is not the most efficient way for it. At least this is the way it's done. But Starknet found like, okay, we can create a better solution, and it would improve the efficiency and improve the transactions even per second. So Starknet, in Starknet, it creates like a new state. So it creates a block, but also creates a proof. And in this case, now the validators don't have to re-execute the program. It has an L1 verifier deployed on Ethereum that can just validate that, okay, this new state is accurate, because again, you can validate the state, you can validate a program without having to re-execute it with Starknet. So you're just going to run, the validators are just going to verify that, okay, this is accurate. So you see in this case, like all validators have to kind of execute the program again, which is inefficient. In this case, it just takes less time and it's more efficient to use. So execute once, verify everywhere. So going to use the example here. So it says like, assuming this is X is what it takes the sequencer to execute a transaction. It takes log square of X to validate it. So if you want to use a diagram to explain it, just like, let's just say X is this, it's kind of scales like in this case. So Prince, okay, Neke said something. Okay, if this is the sequencer execution, it goes here. This one will not require as much in there. Prince, do you want to add to this? I know you mentioned something earlier. I'm going to unmute you. Prince is the TA. Give me a second. Okay, Nika, do you want to add to this?
Yeah, hi everyone. So pretty much in trying to explain the log square X for which serves as an explanation for verification in Cairo, you can see that at some point for verification, the curve starts to flatline, and that is because of the exponent of log square X. So in Cairo, the sequencer pretty much allows us execute transactions in batches, and we're able to verify those transactions as we go because of the exponent of X as a log, which we use in the programming. So it's a little bit of simple math, and you probably don't have to devote any of your time to comprehending all of that. But basically, the idea is for you to understand how it works and how it probably affects Cairo as a programming language and its implementation in actual coding. Pretty much it.
Okay, I'll just add to this that you don't really have to, for you to be able to program in Cairo, you don't need to put all this, you don't need to memorize this, or you don't need to even know this. If you want to just be a programmer, you can just focus on programming, but this is just trying to give you like the fundamentals and explain like how it works. Okay, so we can look at validated proof as like compression. So it's like validated proof is a compression of computation, similar to like zip files, as compression of file size. So I know most of us here have used a zip file for, instead of like you want to send something to your friend, let's say it's like 200 or 10 gigabytes, and you don't have enough space in your computer to, or you don't have enough space to say, you can zip it, just compress it, and then send it so it's a smaller size. So in this case, Validity does that to computation. So you can compress computation and you can use it for whatever use case you need it for. So then validity proof, a use case for zero knowledge proof. So we use validity proof to convince a verifier on L1 of new L2 state without sharing transaction details. And this is kind of like how Starknet uses validity proofs. So it doesn't make L2 transaction private. So what it means is that, yes, we're talking of ZK, zero knowledge proof. Some people might, assume that it's private, but this is not what, Starknet is optimizing for currently. Maybe in the future, they would optimize for like privacy, but right now it's not the case. So it makes verification efficient and succinct. So the use case of validity proof on Starknet too, they use it for validity rollup. I know you could have heard of like ZK rollup. It's kind of the same, in my own opinion, but again, we just call it validity proof on Starknet. It's based on stacks and not snacks, and it's efficient for proving and verification. Just a question. Okay, so this is just a very high-level overview of like stacks and snacks. And so stacks uses the verification of log square n, while snacks is constant, but the proof size of stacks is actually larger than snacks. So like why use stacks in Starknet over snacks? It's like the proving time, it's more efficient than snacks. It doesn't require a trusted setup, while snacks requires one. And stacks is quantum secure, and snack is not. And if you do want to kind of go over this, again, there will be materials there you can use to learn this. But again, it's not like, for this class, we're just going to be going over Cairo. We're going to be dive into Cairo, so you don't need to kind of understand this like on the core level to go over the class. Okay, so why Cairo VM and not EVM? So if you are familiar with like the blockchain programming or Ethereum, you've heard a lot about EVM, and then just Cairo or Starknet is introducing CVM or Cairo VM, and you're like, okay, why not just go with the regular? Because most L2 go with the EVM, but Cairo VM is kind of optimizing for performance. So Starknet wanted to be the most, or wants to be the most performant, L2 scaling solution. So they're like, instead of using EVM, which was not initially created, for ZK, why not build something from the scratch that is, optimized and is created for ZK? And this is where, the Cairo VM was born. And you see a lot of, ZK EVMs, but which are optimizing for compatibility. And it's, it's easier if you're optimizing for compatibility to like port over like all the programs that, it's written, or programs that are written in, what are they calling it, in Solidity over to your L2 solution. But in Starknet, it's more difficult because, again, it's not optimizing for that compatibility, but performance, and it's a new language entirely. But yeah, the case is that, the Cairo VM is optimized for performance, while the ZK VM is not. That's the major difference here. Okay, and talk about L1 finality. Ethereum is the fastest, obviously, because it's the L1. And Starknet is kind of like closely following because it takes 10 hours to reach finality on Starknet, but it takes about 2 seconds now with the latest upgrade of Starknet to reach finality on L2. So, and this is what most users have to worry about, right? So if you want to make a transaction, you make sure it passes on Starknet, and it's very fast in that case. But if you want to use like the native bridge, then you have to worry about this. But in this case, there are a lot of other solutions, alternate solutions that help you. So you don't really have to worry about, the 10 hours. But again, it takes 10 hours to reach finality on layer 1. And then there's the optimistic rollup, which takes about 1 week. They use fraud proof, and it's quite, slow. And I mean, fraud proof is probably not the most efficient way of scaling solution. And you see that most optimistic, or some of the optimistic rollups have started adopting, Stack as their scaling solution. And I'll just give you an example of like the TPS. And TPS just means transaction per second for people that are not familiar with this terminology. So Starknet recently, about 2 weeks ago, reached like 503 TPS transaction per second. That means like they can handle more transaction per second than it used to. And then this is the user operation per second on Starknet. It's peaking. And I'll go over the summary. So why Starknet? This is a summary of why Starknet is optimized for ZK Tech. It's higher compute power. It's reduced gas fee. It's secured by Starks plus Ethereum. And then it's a powerful programming language. It's battle tested. It's processed over like 1 trillion plus. It's processed over 1 trillion also over the past 2 years on transactions. Withdrawal to L1 is like about 10 hours, and it doesn't require a trusted setup. If you all have questions about Starknet, I would like to answer that right now. If you have questions, I will just go over here and see if there are any questions here. That's a nice story. Okay, Winifred, to your question, yes. If you have a background in JavaScript, you should be able to pick it up. You should be able to pick it up. Again, you just have to put in work, but you should be able to pick it up. What's about managing best of both worlds? Olade, I think I missed your question. Can you reference it again? The application. Source. Olade, can you ask your question again? I think I missed that. Okay, Michael, you said what is L1 and L2? L1 is Ethereum in this case, and L2 is Starknet. Ethereum is a blockchain that's, that most people used to do DeFi applications, and L2 Starknet is scaling Ethereum. So there is like a known problem on Ethereum that transactions are quite expensive and it's not as fast, or you cannot do a lot of computation on Ethereum, and this is why Starknet is a solution to build that. Okay, Michael, I would try to probably during this class as we go in, I'll try to explain it further. And if you need extra help, definitely I'll drop my link to my office hours. You can definitely get on a call with me, and I'll try to break it down a bit further if that helps. Is there any other question? Everyone here? Can you leave like a yes? Okay, awesome. Right, I saw a question about Starks and if can use it on other blockchains. Stark again is a proof system, and Starknet is leveraging Starks as the proof system. There's Snarks, but again, you all don't have to worry deeply about it. But if you want to kind of like you're just curious and you want to kind of dive deep into it, you can read this about it, and there's like a short math paper that explains what Stark is. I know that Polygon and Starknet actually collaborated on working on something called Circle Stack. So Polygon is going to be using, I'm assuming they're going to be using, Stark also in some of their feature solutions. Again, it's just a proof system, and Starknet is just leveraging it as a scaling solution for Ethereum in this case. But if you want to dive deeper into this, you can just read a bit about this. And there are probably other YouTube videos you can kind of watch. But this class is not focus on this part of like, it's mostly focused on Cairo, which is the programming language. And we're going to kind of get deeper into this starting next week. Okay, so I'm going to continue. And we're going to talk about smart wallets. So it's a wallet that allows you to use sign transaction with that allows you to sign transaction with Touch ID and Face ID, execute multiple operations in a single transaction. So on Starknet, SN is Starknet, every wallet is a smart wallet, right? There are no EOS, and if you're not, again, I know I've said a lot of acronyms here. EOA means externally owned account. This was kind of like first gen wallets. So if you're familiar with like MetaMask and like Trust Wallet, these wallets are kind of EOS. And now like Starknet is coming with just uses account abstraction, native account abstraction, and all the wallets on Starknet are smart wallets. And some of the examples of this, like Argent and Bravos, I'm going to actually show you a walkthrough of like setting up a Bravos wallet. And we're going to dive deeper into like, smart wallets and like why we're using them on Starknet. Okay, so in this exercise, we're going to just install Bravos extension and then create an account on Sepolia. So to install a Bravos extension, you just need to kind of go to your extension. If you're using Chromium or Chrome, you can go to your extension and marketplace and find the wallet. So we can call it Bravos. I don't know what's wrong with my internet today. I'm not saying anything. I'm just going to go to their website, Bravos, see if that so take us there. So let's try to download it. It should take us to the store. So we say Chromium. And then we'll add it to Chromium. So this is just adding an extension to your account. Easy as that. Okay. So it's downloading it and then it's added it to account. So I'll just pin it here. Click on it. I just need to create a new wallet. So create a wallet and then you put in a password. I'm just putting anything here. So just put in password. Don't do this. This is weak. So I'll put 1, 2, 3 exclamation. Okay, that's not good. I'm just going to use like more secure one. Okay. Just use and then again, it's not good. Don't show anybody your seed phrase. If it leaks here, it's okay. I'm not going to use this wallet anyways. Say I've saved it. You should try to save yours. With a smart wallet, it enables you to, because again, it's actually a program, it's a contract. You can write custom logic. And with Bravos, you enables like 2-factor authentication, 3-factor authentication. And this case is asking us to enable a 2-factor authentication. So I'll do that. And this is going to be using a passkey. In this case, my fingerprint. So I'm going to do this. Okay, I don't know why the pop-up came in. Yeah. Okay, I'm going to try it. I'm not sure what went on there. Okay, I'm going to put my password. Okay. Okay, it says it failed to set up a key sign. I'm not sure why that. I think there's something wrong with how my computer is rendering this. Okay, it worked, but I did not enable my passkey. But in your case, might be different. I think that was just an issue with my computer. I'm going to switch to Sepolia. So there's like Starknet mainnet. This is where you put production stuff. And then Sepolia is like the test network. So everything here is like false. So it's not authentic. So you can actually test here. So you don't have to reuse real money to like, program or test your application. So I just put my network on Sepolia and I'll send some hits to it as gas fee. So give me a second while I do that. And there's like a faucet, which I'm going to leave in the chat. It's not in the chat. I'm going to leave a link to the faucet in a summary of the class so that if you want to test this, you can do that on your time. And we're going to use this while we are, programming and deploying contracts. So you would definitely need to have like a wallet and gas fee there. So I'm going to send you the faucets to get yours. But in this case, this is me deploying there. I should send some ETH on there. So you see 0.3 ETH here. So this is just us setting up an account. If you have any questions, let me know. Nikki just left the link to the faucet. Okay, awesome. So that's us setting up an account. We're going to try to create a transaction down the line, but let's go with this in this case. So install Bravos, create an account. Okay, so sometimes an action requires multiple steps. So we just go down the line. So if you want to create an action, sometimes it requires you to, go multiple steps. So let's say step 1, step 2. You would think that this is, how it's supposed to be packed on a block, on like a regular, blockchain. But no, sometimes it's, there's like step 1, then other people's transaction can be in between, and then step 2, or it might not even be on the same block. And this kind of like leave room for, maybe someone can actually, maybe use MEV attack and, arbitrage or make you even pay more or make your transaction more harmful to you in that case, or you have to pay more money sometimes, which is not the best solution. But with Starknet multi-call, you can have multiple user operation in a single transaction. So in this case, you know that, your transactions will be on the same block, and, it reduces the risk of like MEV on your, in your transactions here, which makes it a bit safer in that case, and cheaper too, if I may recall. Okay, so Starknet also, the key one is the account abstraction, which is the decoupling of signer accounts. So the signer in this case is different from the accounts. And so you can use device that your signer will be the device that signs your transaction and identifies you with a private key. And then while the account is a smart contract on Starknet, which holds your assets, like it verifies your signature from the signer, and it executes transactions with multi-call in some cases. So this is like an example of an account abstraction in practice. It's an high-level overview. So this is like the signer, which can be your wallet, could be your phone. And then, you have an account deployed on, or it could be your computer in this case where, my computer is as a signer, and this account is actually a contract. But if it's, there are no activities here, but you're going to see once I kind of like interact with the contract on there. But anyways, so this is the account interface. It uses like the standard SNIP, which is just Starknet Improvement Proposal. Funny, anybody can write SNIP, but then the community would have to kind of agree on it, and then it becomes a standard and it becomes a SNIP. But yeah, this is the interface for an account. Yeah, so you've seen transactions. So the signer invokes the transaction, while the accounts will verify, validate the signature, and then can execute that transaction on the target contract. Again, this might look abstract to you if it's the first time, hearing this, but I'm going to kind of try to show you an example here. There's a question here. Why does a token need to be approved to make a swap? Well, on Starknet, it doesn't. So if you want to make a swap, you wouldn't need to approve a token on Starknet. This like approval is like on AVM blockchain. One, I don't know if I answered your question. Okay, we're going to try to interact with the smart contract. I'm going to just find smart contract, create a transaction, details in wallet, and explore an account. Actually, think I missed. Well, let's see something. So, all right. So I'm going to try to get up a basic counter contract, and then we're going to use like tool sets, Scarab and Starkly to get everything up and running. So first go with the Scarab new, and then we just call it a counter contract. And we're going to use Starknet Foundry because we want it to be on Starknet because we're going to declare and deploy. So it's going to run and it should deploy. It should create the program. So if you do an ls, you should see it here. So I use a text editor called Z. So we're going to just try to go up and running with this. So you get it. This, again, a counter contract is kind of like the fault that Scrap Package Manager gives you. So we have the LO Starknet, which is just an increase, which again uses a reference. So we're going to be referencing state, and then we're going to, get balance. So again, state storage is balance. Every contract needs storage, even if it's empty, you need a storage. And then we have the Starknet contract macro. Again, a macro is just indeed a rocks function that takes in Cairo code and output Cairo code. But anyways, what we want to focus on right now is this build. So if you do a scar build, it should create like a target folder for you. So you will see a target folder here after it's complete. So just wait a minute, you see a target folder is created. We're going to use Starknet to deploy it. So Starknet declare first. So you have to declare a contract first. So we do the declare. See, oh, yeah, my password was wrong, so I'm gonna put it again. Okay, so interesting. Okay, so let's try again. So Starknet declare, Starknet declare. Then we go to targets, and it's supposed to be dev, and say hello. Then I'll put in password again. I'm not sure what happened this time again. So it should process and then declare. Again, because this has no constructor, we can just do a Starknet deploy. Again, I've set it up to be this way. This is not the default way. And I'm going to show you how to set up it properly in a future contract, but this is simply it. So we've just declared and deployed a contract. So if we take in this, we can actually first see if the transaction works by going here and open a block explorer here. We're on sepal here, so we can just put in this and see if we can find it. So it's already indexed here, it's accepted. You see that the stages was not received, but received, pending, and accepted. So we can try to see if it's already indexed the contract. So we can take a look at this from here. And then try. Sometimes it takes a bit time. Okay, so it's already indexed it, so we can actually go there and then we'll see that it's been deployed. Give me one more minute. So this is the hash declaration transaction. I think I'm looking at a wrong project right now. Okay, so this is the hash. Okay, so this is the deploy contract. So we'll go back here and take a look at this. Okay, so you see it here, and then write. So you see you can read and write. So for you to be able to write, you need to connect your wallet. So we're going to connect our wallet, and then we can just increase the value. So we can increase the value, let's say 2, say write. Then it brings out this, then you sign it. And yes, the transaction went through. You can check by getting balance. Click on get balance. You should be able to see the balance. So it's 2 because we added 2 to it. Okay, let's try again. We add, let's say 4. So 2 plus 4, right? So let's just write it. Yeah. Then we sign transaction. Okay. Then if we go there again, we did a 2 plus 4, right? So if you check this right now, it should be 6. Okay, this works. That's pretty much about it. We're going to go deep dive next week. Let me get like an old contract that I've deployed before and try to use that here. So y'all give me like a second. Okay, so this should show up like as a transaction here. So you'll see that there are 2 transactions here, account deploy, because this is the first time we're trying to use this account that I just deployed, that I just created. It had to deploy the account and then it minted lots. So this is kind of like an example of how the transactions work here. And we'll go back to the slide. But for the issue that I was facing, I'm going to try to kind of like debug that. And then next class, I'm going to show you what it is. And this is where we actually need to use that next class. So we just, interact with the smart contract by minting logs. So we got the contract address, which is this one. We use StackScan, which is like a platform that you can use for kind of, it indexes the block on Starknet. So we pick like a contract that was deployed. And I went here, you can read from the contract and then you can write from the contract. So I went to the right here and then I minted. You have to connect your wallet. So I connected my wallet that I deployed here. And then I just wrote onto the contract. And that's kind of like a basic interaction with the contract here. And then we'll go to the next one, which is signature verification. So signature verification, and because again, it's again a smart account, you can have programmable logic on the account. So this is kind of like you can have features like single signer, multiple signer, hardware signer, social recovery, or session keys. And session keys is going to be like important when we're thinking about, let's think about on-chain gaming, because Starknet, there's like a lot of like, or they've been a rising number of like on-chain games being built on Starknet. And we're actually going to cover this topic on week 5. We're using Dojo Engine. But with session keys, and maybe you all have seen like a joke where you say, okay, on chain gaming, you have like transaction every time, like you want to move, you have to create a transaction, you want to attack. And it's like, it becomes like a very bad user experience. But with session keys, you can like have a policy to like pre-approve these functions that, okay, this function call, you don't need to like sign it every time. So you can, this is thanks to like the smart accounts. And then it supports multiple elliptic curves. We're not going to dive deep into it because it's also a very large topic, but I'll send a link that you can use to kind of dive deep into it from the Node Guardian. They have like a theoretical session where you can learn more about elliptic curves. But again, this is not the core of what the class is going to be about. And this is just a level of account abstraction plus secure enclave. So you see that in like, this is using an iPhone, for example. It has a secure enclave with a dedicated processor and dedicated memory and like a shared system, which is like the shared processor and memory. And this one does like the operating system and application, while you use the secure enclave for like random number generation, crypto key management, hardware signer. And this is using one of like the elliptic curve. And you can manage your keychain, touch ID, and Face ID. And this is what we're gonna, it's used for like the smart wallet, smart accounts on Starknet. So Apple is called Secure Enclave, Google, Titan M, Samsung is Knox, and ARM is Trusted Zone. But yeah, it also applies for laptops too. So a summary of the smart wallet is better UX than regular wallets, multi-call, hardware signer, social recovery, session keys. It's enabled by account abstraction, decouples of signer and account. Account is a smart contract with specific interface. I think I showed you the example with the SNIP6. It supports signing transaction with different elliptic curves. And on Starknet, every wallet is a smart wallet. With no EOA, so there are no externally owned accounts on Starknet. And we're going to skip this exercise, and this is probably the end of the class. If you have questions now, we can answer it, but next week is when the class is going to kind of go deep into Cairo. Today, I just wanted to kind of give you all an overview of like what the class is going to be about, and get you all prepared for like what we're going to be doing. So next week we're going to go over Cairo, and then we're going to start like the stack lane. If you all have any questions, let me know. And